In Unit 3, we're going to learn to take samples for things like political polls, along with how to create experiments to compare, say, a medication with a placebo. In both of those situations, one of the really important parts is selecting people at random. And that's where we start in the unit with Chapter 11, which focuses on how to complete randomization appropriately. To begin, let's define randomization. Randomization produces an outcome that isn't predetermined, and it produces an outcome that's quote unquote fair. One thing to note is that when we get a random number, the range of possibilities don't have to be equally likely. Take rolling a pair of dice, for example. We can get anything from a 2 to a 12. We're much more likely to get a 7 than we are to get a 2. That's okay. We're still getting a random number. People tend to associate randomization as unpredictable. That's true in the short term. We roll 2 dice. We don't know what we're going to get. However, in the long term, randomization is very predictable. We're going to get a 7 about 1/6 of the time. Okay, if we roll the dice enough times, we can estimate approximately how many 7s we'll get. That's how casinos make their money on the craps tables, by making their payouts slightly less than the percentages that those numbers will come up. One of the surprising things is that it's actually quite difficult to produce truly random numbers. Your tiny little brain can't do it. And I'm not saying that to put you down. My tiny little brain can't do it either. The human brain is just incapable of producing truly random numbers. Let's perform a brief test. I'm going to put some numbers on the screen in front of you. As soon as you see them pop up, choose one, commit to it, and then we'll analyze them. Here we go. All right. Did you pick 3? If you did, almost 75% of people pick 3. It's the one that's just favored. We're inclined to pick certain numbers. We have biases. And for whatever reason, just subliminally, okay, more people pick 3. There's nothing random about it. If you picked a 2 or a 4, okay, you're with 20% of the others. And if you picked 1, you are quote unquote unusual. Only about 5% of people choose 1. Pat yourself on the back. Okay, computers do a bit of a better job of producing random numbers, but in actuality, computers can't pick random numbers either, right? We can get a random number by flipping a coin, by rolling a die. Those are simple methods, but to get truly random numbers is actually quite difficult. In fact, most statistics textbooks supply an appendix with something like this, which just has strings and strings of random numbers. This is for when you need truly random values, and these are often populated by taking numbers, quote unquote, at random from digits of pi or something like that, where they're just picking random digits from a string of infinite numbers. So we require randomization for this problem that we're about to do. We're going to use a random number table, and we're going to conduct something called a simulation. A simulation is basically just a replication of a real life scenario in a way that we can control and manipulate our variables. So looking at this example, every Monday a local radio station gives away coupons to 50 people who correctly answer a question. They're numbering these coupons from 1 to 50. The first person receives coupon 1, second person receives coupon 2, etc. On Saturday, this radio station randomly draws 5 separate numbers and award cash prizes to the holders of those coupons. If it's a coupon numbered 1 through 5, they get a value of $200. 6 through 20 gets $100. 21 through 50 gets $50. So the question is, how much money should the radio station expect to award in prizes each week? So here we have our problem condensed with the key information. 50 coupon holders, they're picking 5. If they pick a number 1 through 5, that winner gets $200. 6 through 20 is $100. 21 through 50 is $50. Okay, down here we have our random number table, which we're going to use to simulate choosing these numbers randomly. There are a number of different terms that we need to understand with respect to simulations. The first is the component. The component is just what each number that we are simulating represents. So in this problem, I had talked about drawing winning coupons from these coupon holders. So each number is representing a winning coupon. After the component, we have the trial. A trial typically consists of a number of components. Okay? And again, in this problem, I had talked about how each week the radio station draws 5 winning coupon numbers. So that's the trial. Okay, they'll be picking 5 winning coupon numbers, and at that point we have an outcome. Okay, the outcome's the result of the trial. We want to find out how much money is being paid out to the 5 winners. Okay, and the last step is that we're going to repeat this process a number of times. Okay, the whole point of the simulation is that we can repeat it over and over again, and that allows us to get a response variable. This is always going to be either an average or proportion, and it's really what we're looking for in the problem. So in this case, we want to find the average amount of money that the radio station can expect to pay out to the winners. In a minute, we're going to go back and write our answer the way we would as if it were an FRQ. But before we do that, I just want to show how this whole process plays out. So on the bottom here, we have our random number table, and we're going to view these numbers 2 digits at a time. We have to do these 2 at a time because we have 50 coupons that are distributed by the radio station. If they were giving out 500 or 700 tickets, we would have to view them 3 digits at a time. If they were only giving out, say, 8 or 9 tickets, we could view them 1 digit at a time. So I'm going to look at this middle row here, and we just look at this string of numbers 2 at a time. Okay, and then once we separate them like that, we look at each individual number. 46 would be our first coupon winner. This is over 50. We skip that one. 32 is our next one. 55 over 50, etc. And we keep going until we've picked 5 winning coupons. Just like everything else that we've experienced in this course, we need to write our answers very thoroughly and very specifically in order to get the maximum number of points on FRQs. So first off, we want to define our component and say something like each number that we draw or we simulate is representing 1 winning coupon number. Explain how we will simulate the trial. We're going to choose numbers representing coupon holders until we have 5 winning coupons that are selected. Next, we want to model the outcome. And this is where we get into the specifics of how we're assigning these winners. Okay, view the random number table as 2-digit numbers with the values of 0, 1 to 50 representing each of the coupons. If the selected numbers between 1 and 50, that coupon is a winner. Any numbers outside of that range should be ignored, along with repeat selections. This is something that in most cases we want to have, unless for some reason we are allowed to have repeats, because we don't want to pick the same winning coupon number twice. Number 4, state clearly what the response variable is. The response variable is the total amount of prize money paid out to the 5 winners. And now we're going to go ahead and run our trials. Typically, we would do this at least 3 times. In an actual simulation, we would do it hundreds, if not thousands of times. So 2 digits at a time. 10, this is our first number. 48 is our next. 0, 1 would be after that. 50 and 11. Okay, those are our 5 numbers. From that, we can get our outcome, which is the amount paid, right? This is a $200 ticket because that's between 1 and 5. These are both $100 tickets, and these remaining ones are $50 tickets. So 200, 300, 400, 450, 500. Okay, so the amount paid is $500. Okay, we would repeat that same process through 5 trials. Okay, as we do that, you can see we skipped a bunch of numbers. Anytime that we get a number that's outside of the range of 0, 1 to 50, we just ignore it. If we got any repeat numbers, we ignore it. Sometimes we have to go out decently far, you can see in this trial, until we get 5 valid numbers. Okay, each time we get the amount paid, and we're going to use this to find a response variable. The more times we do this, the more accurate our estimate's going to be. So the response variable will always be either the average across all the trials, or if it's categorical data, it'll be the proportion across all trials. In this case, the average amount paid for the 5 trials is $430. And for our final sentence, we always want to start it with the simulation suggests, just to qualify this as the fact that it's not real life. We might see variation in real data. So the simulation suggests that the radio station should expect to pay an average of $430 each week.